math teacher. My name is Dr. Alj. My first name is Mahmoud. And for the first lesson of the year, we're going to be doing integrals. Who here knows how to do integrals?
We don't know. What are integrals?
Don't worry guys, it's something that you covered last year during your final exam. As seen by this diagram, when you have an equation f of x and an equation f of x prime, to go from f of x to f of x prime, you use the derivative, which you've covered last year. But to go from the other way, from f of x prime to the f of x, you have to use the integral, which we will cover today for the first time. Okay, so as you can see in this example, moving on here, when you have the integral of 1 over x dx, the answer would simply give you ln of x plus c, the c as I said before. But if you look at this example specifically, you're going to see that there's a very interesting pattern, because when you differentiate ln of x, it gives you 1 over x. But when you want to find the integral of 1 over x, the answer is ln of x, so it's basically the antiderivative. So this is something you can refer to when you solve your problems in the further classes. Okay, moving on to the when you have the exponential functions, when you have the integral of e to the x dx, your answer would simply be the same, e to the x, and add the c at the end, which is the the concept of integration.
Can I go off the board, please? Okay, so first you need to separate the x from the constant, so this gives you half times 1 over x power 9 dx. So as this is a constant, you need to remove it from the integral, which gives you half 1 over x power 9 dx. Following that, you need to use the power rules, so you still have the half here. And so this gives you, so you need to put the x up, which gives you x power minus 9 dx. So now you need to integrate the x power negative 9, which gives you half x minus 9 plus 1 over minus 9 plus 1 dx. So that is the power rule, which then gives you half x minus 8 over minus 8 plus c. So then you need to multiply the half with the x, which gives you x minus 8 divided by minus 16 plus c. So that will then give you 1 over negative 16 x power 8 plus c.
Let's focus on the following example. As you guys can see, we have a numerator and a denominator. At a first glance, it might seem quite complicated, but let's break the steps down. First, guys, I would recommend you to rewrite the square root into a power. Later on, guys, we're doing integration and we can unfortunately not apply the quotient rule like we would if we're doing derivatives. So let's simplify this and then apply the subtraction rule for integration. The first step for simplification would be to rewrite the function like this. This will enable us to bring up the x's and get rid of the denominator. And this will lead us to this function, to this final function that we are going to integrate. Yes, guys. So to integrate, we're going to apply the subtraction rule. The subtraction rule means that we have to integrate each part of the function. So this would mean, first this, we're going to integrate the first bit minus the integration of the second bit, the second part of the function. So let's do it. So here we would apply the power rule. So the coefficient and the x come along. So we have 3 and the x come along, and then we have n plus 1. 1 half plus 1 would be 3 halves. And then we would continue. Oh, no guys, sorry. We forgot about, you need to divide by n plus 1. And then we would follow to the next part. So we would do the same, guys. So we have 2 and x come along. Negative 1 half plus 1 would be 1 half and as you guys know, divided by n plus 1, which would be 1/2. And guys, since we're doing integration, we cannot forget about the c, which is really important. But let's try to simplify this even more. Well, not simplify, but let's resolve this. As you guys should know, dividing by 3/2 is the same as multiplying by 2/3. That would give us 2x 3 to the power 2x to the power of 3/2, and then we would do the same here. Dividing by 1/2 is the same as multiplying by 2. So let's do it. So that would be 4x 1/2 plus, as we're doing integration, the c. It's really important to have the c. And guys, this would be the final result of the integration of the following example.
Sir, I can do that example. Can I do it?
That one's hard, huh?
To solve this problem, as teacher explained, when we have 1 over x plus a, we have this formula which is ln of the absolute number of x plus a plus the constant. So in this example, we will have the integral of this would be ln of the absolute number of x plus 3 plus the constant. Okay, so in order to solve this integral concerning e mainly, we first have to look at number 5, which is a constant. And as we have seen, the constant has to go outside of the integral in order to solve it. So this will be 5 integral of e to the power of minus 0.25 x dx. Okay, so what do we have to do now? We have to solve what is inside of the integral, e to the power of minus 0.25x. In order to solve that, we have to look at this rule, which says that e to the power of a variable times a constant, the integral of that is the reciprocate of that constant times e to the power of the constant times the variable. Okay, so here this will be 5 times 1 over 0.25, but as we have here a negative sign, we will have to add it here. Then we have to multiply it by e to the power of minus 25x, and we will have to put it plus c to add the integration constant. Okay, so now we will solve this. 5 times minus 1 over 0.25, it's equal to minus 4. Therefore, times e to the power of 0.25 times x plus c. Okay, so now we just have to simplify it by multiplying 5 minus 4, which is minus 20, times e minus 0.25 x plus the constant.
May I go up and do an example on marginal cost?
So I'm going to be exploring marginal cost and total cost. These are two commonly known functions in the business world and are extremely useful. Now, total cost is generally known as C of x. Well, marginal cost is just the derivative of it. So it would be C prime of x. And this is the general idea that it is known within the business world. Now, the other concept that can be applied, or in the other way marginal cost can be interpreted, is as the cost of producing an additional unit. Now, this unit can be, well, it varies on the business sector clearly that you're in. Now, from a graphical perspective, let's say that the cost function, in this case, would be like this. Now, let's say at this point we have a tangent going through. Now, at this point, the tangent and the graph will have the same gradient. In a specific example, we're asked to find this total cost. Well, the derivative is given the marginal cost. So let's say we have the marginal cost and we want to find the total cost. Now how do we do this? Well, it's just the antiderivative, or in other words known as the integral of units. So let's work through this. First, let's apply the proper notation. So c of x would be the integral of x to the 1 over 4 plus 6 dx. Applying the subtraction and addition property, we know that c of x then will equal the integral of x to the power 1 over 4 dx plus the integral of 6 dx. Therefore, now we're integrating by parts. First, this integral would be applying the power rule, x to n plus 1, which would be 5 over 4, divided by n plus 1, which is 5 over 4, plus the integration of this number, which is a constant with no variable next to it. Therefore, it would just become 6x. Now, let's not forget the most important thing, which is the constant of integration. Now, generally, if we were just asked to integrate, this would be the proper answer. However, we're asked to find the original cost function in order to find what's the cost producing 16 units. Therefore, how do we find c, the constant of integration? Well, we're told that c of 0 equals 145. Therefore, 145 equals 4 times 0 to the power of 5 over 4 divided by 5 plus 6 times 0 plus c. Now 145 equals c. Now let's take this back to the equation and insert it. This would mean that the cost function equals 4x to the power of 5 over 4 over 5 plus 6x plus 145, which is the constant of integration. And now we have the final cost function. So therefore, let's go ahead and find what's the cost of producing 16 units. So c of 16 would mean that 4 times 16 to the power of 5 over 4 times 5 over 5 plus 6 times 16 plus 145 equals 266.6. Therefore, final answer is that the cost of producing 16 units is $266.6.